Yan. So, congratulations po na sa ating top 3. So, may bragging rights po kayo ulit. And hopefully, no, yung mga pagsagot nyo no, in the exams or in the Kahoot no, will help really enforce yung mga natutunan. No? Yan. Okay, so continue po natin yung discussion no, sa ating course no, for today or ating webinar for today. Here no, in the next few slides, no, we will go over in detail the different parts of the RIC. Before that, no, we also first have to go over review no, of the RU and BBU in the OSI model. So we are already familiar that the BBU and RU are split parts, baseband unit and remote radio unit. They're connected using the front haul interface. So which front haul interface? It depends on the assigned the protocols, which we will see later when we discuss the functional splits. Okay, but you can see here the different RAN protocols and the corresponding OSI layer that they are under, no? And the functions of each part. You can see the RF part no, is at the lower physical layer of the OSI model. And the functions is more on analog to digital converters, and then digital to analog conversion. So more on the conversion between analog to digital. The phi layer here, the high physical layer, is more on modulation, demodulation, error correction, and MAC layer, multiplexing, the radio link control, more on segmentation, error correction, and automatic retransmission request. We have PDCP, IP header compression, since it's coming from the network layer, so you more likely have internet protocol packet. And then in the network layer, we have RRC. This is the connection management and mobility functions. And then SDAP is more on the QoS flow handling. And this is only applicable at the 5G RAN. It's not available in the 4G RAN. Okay, so which particular protocol is applied? It depends on the functional split. So when we split the baseband unit into two parts, this is summarized no, in the 3GPP technical report 38.801. There is a split RAN architecture wherein the BBU is split into the centralized unit and the distributed unit. Because they are separated, so they now have an interface. So to connect each other, we have the mid-haul interface. Okay, so whatever the function of this centralized unit and distributed unit depends on the functional split implementations that the mobile network operator is using. Okay, so specific na protocols under DU and specific protocols under CU no, depend on where in the model earlier no, is the split occurring. Is the split between the layer 1 and 2? Is the split between the layer 2 and 3 and so on? So basically in functional split, the different protocol layers will reside in different components. Yung protocols that we have seen in the previous slides. And then the reason for having different split options is that for flexibility, and it depends. It varies depending on deployment constraints. Will you prefer to pull most of the functions at the centralized location, or are you willing, or are you okay to deploy it nearer the cell site? And the standardization of these splits would enable the use of solutions from different vendors. If there is a standard that being followed by the manufacturers, by the vendors, then it's easier to mix and match the component, mix and match the BBU, mix and match the DU, CU, and the mid-haul interface. Okay, so these are the three key factors in selecting or in influencing the split choice: the specific quality of service, the user density, and the transport network, so that are in the particular network of the telco. Okay, so functional split overview describes what are the components of the RAN. In the monolithic RAN, we just have the RU and BBU. But in the RAN functional split, we have now the three. So we have the CU, DU, and RU. So there are three different types of split. One is the low layer split. That means at the lower layer of the OSI model. So it will basically define what is the function of the RU and the function of the baseband unit. So nandito sa banda yung split na yun. And then the high layer split, HLS, is defining what are the functions of the CU and the combined DU and RU. And finally, the dual split, dual split. So you are implementing two types of split: the lower layer, the low layer, and the high layer splits. Okay, so yeah, because of that, we can allow the implementations of more flexible implementation, and it could be also interoperable with other vendors. Okay, so first, let's look at the functional split options 1 and 2. This is the high layer splits because you are going to split the functions at the upper layers of the OSI model. So if you split the protocol stack in this part, dito sa part ng RRC SDAP, that is what we call the option 1. You can see here the centralized unit is in charge of the SDAP and the RRC, and yung remaining protocols, or remaining protocols, RAN layer protocols, are hosted at the DU and RRU. So the DU and RRU can be co-located, or they are also referred to as RDU. Okay, so there are just two main blocks here. We have the CU and the integrated DU and RU. There is, of course, a front haul, sorry, not front haul, but a mid-haul interface, F1. Confusing kasi F, pero not a front haul. It's a mid-haul interface. It connects the two, the CU and the DU. And this particular split option, or rather the high layer split, is desirable for capacity use cases wherein there is a dense urban area. So majority of the functions are already at the location of the site. So co-located po yung several functions. So ano siya? A lot of the processing is required within that area. Kasi it's very dense, high population, high number of customers. But this is, of course, largely dependent on the front haul performance. Kasi there should be a good front haul for performance here since it's not co-located with the CU. Ganun din, similarly for option 2, ang pinagkaiba lang ni 1 at 2, instead of splitting it at the layer 2 and 3, you are splitting it within the layer 2 of the OSI model, between the RLC and PDCP. Okay, so if we go back dun sa kaninang slide, ano ba yung functions nun? Yan. Andito siya, So the IP header compression will be hosted at the CU, and then the segmentation end towards the lower is hosted at the integrated DU and RRU. So options 1 and 2 are high layer splits. And then now we have the low layer split. So name pa lang low layer, so it's focusing on splitting the functionalities of the lower layers. And at the lower layers, we have the RF and the Phi layer. So meron tayong low Phi, low physical, and high Phi. Okay, so yung option number 8 natin here is a split between the RF and the physical layer. So the RU function is only for radio frequency, so for analog digital conversion, while the CU and DU, the integrated CU and DU, is hosting all the other RAN protocols. Okay, so later we'll describe each of these split options further. Okay, option 7, as you can see, the physical layer is further subdivided into the low and the Phi. And then here, still, you have an RU and the CU, DU. Option 6 here is the separation, the split between the layer 1 and layer 2 of the OSI model. And still, now we have two blocks here. We have the integrated CU and DU plus the RU. Okay, so since may separation po ng RU at saka ng baseband unit, then meron po dyan, of course, na front hall interfaces. Okay. You can see as well, no, mostly this kind of split options is better, no, for coverage cases that involve rural areas, wherein you'll have minimal equipment hosted at the site, but you have mostly focused on the radio frequency portion, the physical layers. No? And a lot of the processing would be hosted at the centralized area, where it is pulled. I saw option number 6. No? In option number 6, separation between the PHY and MAC. This one uses a front hall interface called NFAPI. NFAPI is a functional application platform interface. It is an API for hardware components implementing 3GPP physical layer functions and software stacks. So this is this NFAPI is defined by the small cell forum, and this allows to connect the small radio unit to the SCU SDU. So if you see S, that means it's for a small cell RAN. So the femtocells, picocells, microcells, mostly for in-building and outdoor wireless service for service extensions. Option 7. Option 7 here is where we split yung dalawang PHY parts or protocols. This is mostly using the front hall interface called EC3, defined by ORAN. So this is more preferred for delay-sensitive services, and this allows pooling, sharing while maintaining low processing on DU and RU, and good option for distributed RAN deployment, including massive MIMOs. Okay, so the CU functionality may be embedded on the same server, or it can be pushed back up to the network as a virtualized aggregation entity along with the RAN controller aggregator. So ang takeaway here is kung nasaan po yung split 7, no? Actually, there are other split options pa, no? May mga 7.1, 7.2, no? But just an overview first of the functional split. Ito po yung option 7. Option 8. Option 8 is mas minimal yung functions ni RU, no? RF siya. This is highly effective in 2G and 3G networks, no? When traffic and processing rates are lower. It allows centralized traffic aggregation from RUs, and the baseband resources are centrally pooled. This kind of connection, the front hall connection here, is using CPRI front hall interface. It was a vendor-specific na interface, so hindi talaga siya open. But later, this kind of setup utilizes the EC3, which is now an open front hall interface. Ayan. Okay, so this option 8 is majorly used before for pre-5G implementation, but since naging open yung CPRI, then rin siya, it becomes more and more used. Okay, so in summary, this functional splits can be summarized as shown in this slide. So meron po tayong options 1 to 8. And then may options 3, 4, and 5 pa, pero it's not as used or not as research. And then the options 1 and 2 interfaces rely on the mid-hall interface called F1. So it's the interface between CU and DU, defined by 3GPP. Options 6, 7, and 8 rely on the front hall interface. It is the interface between DU and RU. And these are the different interfaces that are applicable under each option. We have NFAPI by small cell forum, EC3 by ORAN. Okay, so that's the high layer split and low layer split. You can also have a dual layer split, a combination of each of the two. So pwedeng option 2 and then option 7. And then ang mangyari is the upper layers will be on the centralized unit, the middle layers sa distributed unit, and the lower layers sa radio unit. No? The operators and vendors can select a split variant that is applicable to them, no? Applicable to their design and their operations. Okay, so this is another way na to look at the functional split options. No? The layer 1 functions, the layer 2 functions, layer 3 functions, horizontal lang. No? But you can see the different options here as well. No? Option 1 until option 8. Okay, so from that, now we have the following sample deployment scenarios. We have the CU, DU, and RU. So here you can see at the first deployment scenario, all of the three are independent from each other. They can be located at different parts. No? We have the front hall interface here, the mid hall interface. No? They can be kilometers away, no, from each other. And the second one is the co-located CU and DU. So you can see CU and DU are in the same site. No, there is no mid hall interface, and we only have the front hall interface here. And then here, in the scenario 3, you have a co-located DU and RU. Here, of course, we have mid-hall interface. And then the front hall interface is very short. No? There is still a front hall interface here, no? The cable, no? But it's more likely just meters away. So yung connection ng D and RU are just meters away. No? And then lastly, the RU, DU, and CU are all integrated in the same site. No? Wala ng front hall and mid hall, but mostly back hall lang po siya. No? Papunta na sa taas, papunta na sa core network. This is mostly used, no, in small cells, mga hotspot scenarios. No? Okay, so all of this deployment scenarios are summarized, no, in this ITUT technical report. No? So if you search, no, for this technical report, you should be able to see this sample deployment scenarios. Okay, and then another way, no, to look at the functional split. No, this is one provided by the Small Cell Forum. They offer different RAN solutions, whether it is integrated, no, single product solution lang. The product solution would have the RU, DU, and the CU integrated in one block. Or we have a disaggregated solution. The product solution can be just based on single split. So whether it's just an option 2 split, option 6, option 7, or option 8. But option 8 is proprietary because the CPRI front hall interface is proprietary. The other disaggregated solution now combines the low layer and high layer splits. So you have dual split options. Here you have option 2 and 6, no? Combination lang ng dalawa. It's based on 3GPP and Small Cell Forum standard. Options 2 and 7, 3GPP and ORAN naman. Then option 2 and 8, 3GPP and proprietary standard, depending on the implementation of the vendor. No? Yeah. So this is the view of the functional splits by Small Cell Forum. We have a 1 product solution, a 2 product solution, or a 3 product solutions. No? So ito lahat, no, lahat ng tatlo, RU, DU, CU isa lang block. Ito may dalawang parang block. No? Ito may tatlong parang block. Okay, so this is also another way, no, to look at the different functional splits. No? This 5, no, this split 5, split 2, 5, 6, 7, and 8. No? They are mostly very more common compared to the other options. And here may naka-indicate din parang approximate na delay that is expected to them. Here the ideal delay is less than 100 microsecond. Kasi kailangan, no, yung functions here mapadala kagad para ma-convert to RF. No? But here you can see it's not ideal. No, it takes longer time. But since it's the higher layer functions naman, no, then it's not as parang critical, no, to sending data. No? Okay, so naka-indicate din yung best performance improvement and expected na parang rates, no? Rates for the particular interface. Okay, so now no, let's have another question ulit, no? Review ulit tayo, no? So this is the high level na ORAN, non-real-time or IC architecture. So baka memorize yun na ito, no? But let's answer po, no? The two questions. What is the question number 1? What is the block on this color blue? Bilis mag-type. So this is again the non-real-time RIC. It's in the SMO. Teka, ayan, SMO. And this is connected pababa, no? Dun sa kanyang, may kausap siya dito. Unknown din. How about number 2? What is number 2? What is this interface? Okay, so it's the A1 interface. This is the southbound interface. No? Pag narinig niyo yung southbound kasi it's from the orchestration, no, the SMO, pababa, no, dun sa pinaka RAN, no, pinaka RAN. No? Okay, another question. A single question lang to, no, pero I made all the other parts blank para hindi walang less cheat sheet, no. So in this architecture for near real-time RIC, what is the interface that is considered the southbound interface? Okay, so yung kanina, sorry, dapat yung kanina northbound, no, pataas. Isa naman southbound, no, pababa. No? So that is the E2 interface. No? Okay, so iba po yung E1 interface. So this one, A1, ito E2 interface. No? Yun po yung tatandaan nyo. Pag narinig nyo yung E2, yan yung connection, no, ng near real-time RIC papunta sa iba't ibang nodes ng E2. Ito yung natanong before, no, last week ata in the Kahoot. The E2 nodes, no, consists of the OCU, DU, no, and yung E node B. No. I think may question pa ulit. No? Ayan, so here you can see the different RAN protocols. And may mga corresponding na mga blocks, etc. No? Ang question here, no, which is the functional split applicable to each one? No? So, what about number 1? No? What functional split is applicable in this first question? Yan, pwede mag-Google kapag, syempre, kakaturo lang, no? Ano kaya yung functional split na ito? Ay, mali. Ano yung isa? Okay, so actually this is option 7. No? Yung option 8 po is when you have the split at the RF. No? Kapag nandun sa middle ng physical layer, it's option 7. So ito option 8, option 7, no? 6, etc. Ayan. So mabibilang mo na. No? Here, if you have the option 2 here, if you have the split here, that means it's option 2. Then, ayan, mapipredict mo na rin from 8, 7, 6, 5, 4, 4, I'm sorry, 8, 7, 6, 5, 4, 3, 2, 1. So, yung last question is 2 and 7. No? Kasi dalawa po yung parang splits natin here. You have the CU-DU split, no? At saka yung RU-DU split. Kamali yung napakita na kagad yung sagot. Okay, so hopefully you understood what it means, what functional split means. It's just how the functions of the RAN is separated or assigned to each of the RAN component. Ngayon naman, let's go over some other important parts of the slides, or some important parts of the RIC. One is the RAN the RAN control loops. In the RAN control loops, there are di pala kita. Let's first look at the overall architecture of ORAN. We have seen this previously in the previous discussion. So merong of course SMO, near real-time RIC, the OCU block consisting of CU, CP, and CU, UP. Andito po actually yung E1 interface, no? It's not it's not the southbound interface. No? It's this interface here, ODU, ORU. Yeah, so here you can see the summary of the different interfaces, no? Starting from the bottom, no? So the front hall interface connecting the DU-RU, F1 interface connecting the DU and the CU. E1 interface is within the CU only. E2 interface is the interface relevant to the near real-time RIC. This is in the working group 3, no? And then you also have the A1 interface. This is called the northbound interface, connecting the near real-time RIC to the SMO. And meron pa pong O1, no? Nakikita dito sa slides, no? Saka O2. No? So yun po yung makikita pag binalikan nyo po yung ORAN architecture. Okay, so there are 4 functional software elements in this ORAN architecture. You have the DU, the multi-rat CU, the near real-time RIC, and SMO with the non-real-time RIC. So each of these elements can be deployed as virtualized network functions or containers to distribute the capacity across multiple network elements with security isolation and scalable resource isolation. We are already familiar that the RAN optimization can be done using AI and ML or machine learning. And the non-real-time RIC is at the SMO. Well, the near real-time RIC is not necessarily at the SMO. Okay, so here also we'll see the different loops in the RAN. We have the non-real-time RIC control loop and the near real-time RIC control loop, as well as the ODU scheduler control loop. So the control loop is just the loop in the non-real-time RICs and the near real-time RICs. And then we have the ODU scheduler control loop. This one is within ODU. This is responsible for scheduling the hybrid automatic repeat request and also beam forming. Okay. And also here you can see the different interfaces and what components they are connected to. They are defined by a different organization, and they are also known as other, like an ORAN interface or 3GPP interface. Again, so front hall, it's from the RU to DU. This F1 is the mid hall, DU to CU. E1 is just the connection between the 2 planes of the CU. E2 is the southbound interface. A1 is the northbound interface. O1 is also a northbound interface. This is for data collection and control for OAM of multi-vendor ORAN functions. O2 is to support the cloud infrastructure. So, diba, in the architecture of the ORAN, there is an O2 interface connecting the SMO to the O cloud. That's the O2. Okay, now let's look at the R apps and X apps. Okay, so again, the R apps are the tasks that are hosted at the non-real-time RIC. Pag narinig nyo yung non-real-time RIC, it means greater than 1 second latency, at least. And this is independent of the non-real-time RIC, although it's hosted there. The R apps are value-added microservices to support and facilitate RAN optimization operations. So like policy guidance, enrichment, information, configuration management, and data analytics. For example, yung R apps can pertain to tasks that, for example, require traffic forecasting. So to be able to predict the behavior of the network traffic, you need to have the knowledge of the past traffic, historical data, and you need to generate first the model of the machine learning, and then apply it later. So that task itself, the training of the machine learning model, definitely requires more than 1 second. It's not a fast process, and this can be done at the SMO framework. Okay, so because it needs to collect the data from the near real-time RIC, so that the near real-time RIC is not bogged down with the task. Papasa niya sa taas para yung si SMO yung bahala sa pag-manage, pag-prepare ng mga intelligence na yun. X apps, on the other hand, is at the near real-time RIC. And near real-time, it's almost real-time. It's less than 1 second. although it's hosted at the near real-time RIC, it's independent of it. No? It may have different X apps, no, implemented there. These X apps are microservices that can be used to perform radio resource management. No? Okay, so since it's the one, no, closest to the RAN, closest to the radio unit, no, then it is the one that can optimize them. No? So it's more on the operations talaga, no, of the radio access network. No? For example, network slicing, scheduling tasks. Okay, so let's look at the R app. Now, these are some examples of our app applications or our app examples. You can see there are 3 examples here. We have our app R, RF signal predictor. It gets the information, no, from O1 experienced by the UE for serving neighbor cells measurement. No? The purpose of this is for prediction of the location of the UE. Maybe more on the purpose is to, if we know where the UE is, it will easily understand, no, whether it needs handover to the other cell or not. And also this way, no, by knowing where the UE is, it can optimize or determine what area would need further improvement in the coverage, or where most of the user equipment are found. So maybe if they're more on concentrated in that area, you can deploy a small cell there. Our AppU, or cell utilization predictor, consumes cell utilization measurements and regarding actual capacity utilization for a cell site over time. This is what the trend of cell site utilization based on trend. Which cell sites would have a large amount of traffic or a large amount of utilization, and you can use that as a case of to determine where to deploy more cell sites. Our AppQ, or UEQOE predictor. No, QoE is quality of experience. No? It's one way to measure whether the end user is happy with the service or not. No? So it measures the UE RF signal and the measurement of cell site capacity utilization, and then it is predicting what is the quality of experience of the UE. No? Even though it's not really reported directly, but somehow you can calculate it, you can predict the value of this. Okay, so all of this, of course, are software, no, parang microservices sila that can be deployed at the non-real-time RIC to overall look at the big picture of the whole operation of the RAN. My X apps, some examples, no, or use cases of X apps. It can be used, no, for automation of network optimization or any specific RAN customization, and also other innovation in the RAN. So there are, of course, companies so that deploy their own X apps, like AT&T and Nokia. They have the measurement campaign X app, automated neighbor relation X app, and admission control X app. So if you search X apps and then the company, it will bring up some information on them. Parallel Wireless also offers X apps, which are virtualized functions of the different nodes. So it's not necessarily just 5G, but you can also have a base station controller 2G, pero it's virtualized, or 3G radio network controller, and 4G X2 gateways. So the X2 gateways is to connect to other nodes. Okay, so we're almost there. We're almost finished. No, just maybe 10 slides left, no, in this lecture, but we'll go over them quickly since it's nearing the time. No, I'm not sure if maybe Richard can send me a text na kung ano na, kung sobrang nag-overtime na. Okay, so let's look at the non-real-time RIC architecture again. We know that non-real-time RIC provides the platform for our apps. It supports the tasks that require greater than 1 second latency, like for analytics, model training, ganyan. It supports non-real-time intelligent radio source management, more on higher layer procedure optimization. Okay, so we have seen this earlier. We have seen that we have the high-level ORAN non-RT RIC architecture. And the important interface here is the A1 interface and the O1 interface. The A1 interface connects the non-RT RIC and the near RT RIC. So actually may mas detail pa po yung ating non-RT RIC architecture. So ito medyo blank pa siya kasi may lalabas mamaya ng mga parts. You can see here the SMO framework. Then there are terminations where the interfaces are connected, and some the non-RTRIC. Okay, so in the non-RTRIC framework, there are the R apps here and some functions for A1 and other things. Then of course the R apps themselves. The R apps are connected to the non-RTRIC via the R1. This is an open API for R apps. API means Application Programming Interface. Then, aside from that, the non-RTRIC connects to the SMO. There's an internal interface. So there are different functions. You can see here the intelligence, like the AI, ML, any human-machine termination, and so on. Okay. So we will not be able to have time to discuss each of this part in detail due to the time constraints. Okay, for the near real-time RIC architecture, again, in near real-time RIC, this is the platform for X apps for configuration, optimization decisions for multi-vendor RAN, and uses AI for intelligent management. This near real-time RIC interacts with the non-real-time RIC via the A1 interface. So this A1 interface is the northbound interface. So this A1 interface is used to send and receive the trained models, the trained machine learning models for deployment and for basically for operation na talaga. Yan. So here is the near real-time RIC internal architecture. Previously, pinakita ko itong slide na to, pero marami natanggal. But in this case, you can see, again, the near real-time RIC connected to the non-real-time RIC via A1 interface. And then, nakakonect din po siya southbound via the E2 interface. The E2 nodes are the OCU, OCU, ODU, and eNode Bs, and then the X apps, whatever the X app is implemented. And the deployment of this near real-time RIC can be done as a centralized manner or a distributed manner. In this case, you can see the centralized near real-time RIC. It can serve 4G and 5G simultaneously. You'll have one part that is serving only 5G. The other part serves both 4G and 5G. You'll know that it is also serving 4G because you can see the eNode B here. And then if it's only serving 4G, then you don't have any of the DU, CU, etc. But you only have the eNode B. Okay, so again, andyan yung dalawang interface, the A1, the northbound interface, and the E2, the southbound interface. Okay, so this is another way to have to implement the near real-time RIC. We'll have a distributed near real-time RIC, wherein you can see that there is one physical near real-time RIC, but it consists of more logical RICs or near real-time RICs. This is maybe one physical device, but there are several logical devices, virtualized functions. Okay. And that is it. That is it for today's presentation of our course on RAN Intelligent Controller. So just a summary, before we end, just we're looking at the RIC, RIC as the enables the management of radio resources and radio networks. enables functionalities for network intelligence, resource assurance, etc. And the functional split is defined so that we know which run functions is assigned to each component, to the CU, DU, RE. And then the vendors, the operators, can select which split variants are appropriate. The three RAN control loops are non-RTRIC, near-RTRIC, and ODU, scheduler control loops. And we already know that the non-RTRIC supports the tasks that are more than 1 second, like the R apps, while the near-RTRIC supports tasks that requires less than 1 second latency. So we have the R apps and X apps. Just remember, R apps is at the non-real-time RIC. X apps is at the near real-time RIC. R apps is mostly on the configuration management and data analytics, while X apps mostly performing radio resource management, since it is the one nearest the radio access network. Okay, so here are some further readings and videos. You can perhaps look into this. Some of these are YouTube videos, so if you can watch them, then it will really help you understand the RAN intelligent controller. Okay, so that's it for my session today. Thank you very much for listening. Hopefully you learned a lot. Thank you.
Thank you, Jacel. Thank you for delivering the RAN intelligent controller topic. Actually, that is one of the most difficult topic sa pagdating sa Open RAN, the RAN intelligent controller. And thank you for Jacel to in simplifying the topic for today. Anyway, so thank you very much. And